For Chapter 9, we're going to be talking about testing a claim. So this first section, we're talking about significance tests and just the basics. This chapter is going to follow closely to what the previous chapter on confidence intervals did, where we take a moment to talk about just the basic setup and conclusion for the content, and then the two sections that follow will look particularly about proportions and then about means. So this whole section has 4 learning targets. We're going to break this up into three videos. So the overall objectives are stating appropriate hypotheses for a significance test, which is going to be this video. Then our second video is going to be about the next two, interpreting a p-value in context of the situation and drawing an appropriate conclusion. Then the last video is going to be about interpreting type 1 and type 2 errors and the consequence of each of them. So a significance test starts with a hypothesis. Significance tests are also called hypothesis tests. So this chapter is really like a complement to what confidence intervals are. So the two most common methods for statistical inference are confidence intervals and then our hypothesis test. So we're going to see some similarities between the two, but then we'll see a particular problem done in each of the following sections for proportions and means, where you can see the two processes, confidence intervals and hypothesis testing. You can see them side by side to see their similarities and how the conclusions that you receive from both of them are the same. However, you'll see some subtle differences between the two. So a significance test, it's a formal procedure used when you're deciding between completing claims, which are the hypotheses. So all the hypotheses, you need to remember, are statements about the parameter. So you'll be using rho for proportion, looks like a p, and then mu for mean. We do not use the English alphabet in the hypotheses, yet we use our Greek symbols. So you start with the null and alternative hypotheses. So the claim that we have evidence against for the significance test is called the null hypothesis. So this is typically what the claim is from a manufacturer, from a company. This is what they state. But what we're trying to do is find evidence for the alternative, saying, oh, actually, we are doubting the claim, and this is the direction in which we're doubting. It's under or over. So an example here is a free throw shooter claims that his long run proportion of made free throws is p equals 0.8, but we suspect that the player is exaggerating. This could be from seeing the player make free throws in previous games, at practice, just previous experience. So the null hypothesis is denoted by h sub 0. Okay, so you start with here in this particular situation, h sub 0 is p is equal to 0.8 because that's what he claims. That's his claim. And then the alternative, h sub a, is that p is less than 0 because we suspect he's exaggerating. There's also a part where you can do no difference. So we'll see. So there are two types of hypothesis tests or alternative hypotheses. So you have what's called a one-sided and then a two-sided, or a one-tail and a two-tail. So a one-sided test would be if it specifically says greater than or less than the null value. So here we see less than 0.8, meaning we think he exaggerated, or greater than 0.8. Maybe we think that he is not confident in his ability, yet we know he's better than that. But then the two-sided is if the parameter is different. So we're not worried if it's greater or if it's less. We just want to know if it's different than that. So it could be either or. So that's when we have the not equal to. So here let's just practice setting up those hypotheses. So at the Hawaiian Pineapple Company, managers are interested in the size of the pineapples grown in the company's fields. Last year, the mean weight of the pineapples harvested from one large field was 31 ounces. A different irrigation system was installed in the field after the growing season. Managers wonder if this change will affect the mean weight of pineapples grown in the field this year. State appropriate hypotheses for performing a significance test. Be sure to define the parameter of interest. Okay, make sure we define. So we'll start with our hypotheses here. Our null hypothesis is the claim that what it was 31 ounces. So here we have the null hypothesis. Now the alternative, we need to go back and look at this statement. It says, managers wonder if this change will affect the mean weight of pineapples grown in the field this year. There's no direct direction for the change. Is it greater than? Is it less than? It does not say that. It just says, will it affect? So that's why in our alternative hypotheses, we strictly have not equal to, because we would love if it's greater, but we also want to know if it's less than. So then the final part of stating your hypotheses is defining your variable, your parameter. So this is where we state, well, what does mu represent? Well, mu is equal to the true mean weight of all pineapples grown in the field this year. So a couple of things here. The hypotheses should express the belief or suspicion before you see the data, right? You're not going to see data and then say what you hope to find and then find it. I mean, that's kind of backwards there. Also, for the AP exam, make sure your hypotheses always refer to the population, not the sample. So do not have p hat or x bar written in your hypotheses. Again, it should be rho, the p looking Greek letter for proportions, and mu for the means, for averages.